Now that you understand how to deploy a service on TrueFoundry, let's understand how can you do advanced configurations for that service. And while there are a lot of things that you can do, we will cover some of the more important ones. So let's navigate back to the platform and open up the deployment form. So this is where we were. If you click on show advanced fields, you will see that these fields come up. And firstly, we will cover replicas, which enables autoscaling. Now, why is this important? When you're deploying a service, you can provision multiple instances of your container or pods so that the incoming traffic is load balanced across the multiple instances. And we are referring to each such instance as a replica in TrueFoundry. The default value of replica is 1, but while this is fine for dev purposes, this is not the best choice for production workloads. Because let's say if a replica goes down, the entire service goes down. And it can also be the case that a single replica cannot handle all of the incoming traffic. So to increase the number of replicas, you can either mention that here directly, or you can enable autoscaling, which can take different autoscaling strategies depending on some configuration of incoming traffic or CPU usage. You can configure it based on CPU utilization percent, requests per second, or even the time range. Now note that you can also pause and resume the service. If you pause the service, it means that all replicas of your service will be shut down and your service will no longer consume any resources, but you will still have that configuration in place so you can just restart. However, if you think about it, this is a manual step. A lot of services and models that are deployed are not used all the time. And let's think about weekends or off-office hours. So while we provide this pause resume service feature, it's better to have an automated feature, which is auto shutdown. This will automatically bring down all the replicas if no requests are received for some time. And you can mention this. And the configuration is preserved. As soon as a new request comes up after the auto shutdown has occurred, the service will automatically get started. Now note that when it's getting restarted, the start will have a delay, which is the cold start time, since it might first need to download the image and then start the service. So this feature is very commonly used and best suited for development environments, not for production environments. You can mention the idle timeout parameter here. This is the number of seconds after which the service will be scaled to 0 if there are no requests. So let's disable this for now. The next aspect is rollout strategy. Rolling out a new version of your application should not incur any downtime, especially for production workloads. So basically you can configure this rollout strategy, and there are 3 strategies. The rolling update is a deployment strategy where your old version of application is seamlessly replaced with a new one, ensuring a gradual transition, right? So you can configure max surge and the max unavailable percent parameters. The canary strategy is a very cautious approach to rolling out updates where a small subset of users or traffic gets to try out the new version first before it's made available to everyone. So with canary strategy, you can have multiple steps. You can add the steps and you can set the traffic weight to a certain percent for the new update, after which it pauses for a certain set of seconds. So you can add multiple steps and accordingly, you can either configure an automated movement to the next step or a manual trigger. Then you have the blue-green strategy, which ensures transition between different versions by maintaining 2 identical environments, one for the current version and one for the new version, which is the green version. Now note that you can also have auto promotion after a few number of seconds, post which the new version is automatically live. Now, one important caveat here is that you need double the number of replicas that you have for one version, right? So if you have 12 replicas for the original version, if you are having the new version as well, you need a total of 24 replicas for the blue-green strategy. And while cloud can scale easily for CPU machines, this assumption might not hold true for GPU machines and on-prem infra. Now let's go through these 3 probes. But first, let's start with the liveness and the readiness probes. The liveness probe checks whether the service's replica is healthy. If the service is not healthy, the replica will be terminated and another one will be started. The readiness probe, on the other hand, it checks whether the service's replica is ready to receive traffic and serve requests. Unless the readiness probe succeeds, no incoming traffic will be routed to this particular replica. And a startup probe is a specialized probe of liveness probe. This probe is only executed at startup for liveness checks, unlike liveness and readiness probes, which are more run periodically. Now let's look at how can you configure these. So let us just configure liveness probe for now. Let's mention the path to the health check endpoint. Port is 8000 and failure threshold is the number of failures before the container is down. Initial delay seconds. Let's keep these default settings and we are good. Once you have configured this, make sure that your endpoint is actually active. So you have to edit the server.py file to have this particular endpoint which checks for the liveness as well. And what this will do, this probe, is that it will check this at regular intervals and it will basically check for the liveness. Another thing is mounts. So in some applications, you might need a file to be present at a certain path for the app to work, or you have data in directories that need to be mounted for the app to work. So you can mount data to your service either by mounting a volume, a secret, or a string. Another important thing is about redirecting and mirroring traffic, which you can do via intercepts. So if you click here, you can allow intercepts, which provide a way to attach ad hoc routing rules for a service deployed. You can redirect traffic arriving at a service to another service on the basis of a header. So it is very useful to test a new release by intercepting the traffic on the main service and redirecting it to the cockpit service. All right, so let's look at one last thing, which is how you can set up CI/CD, and you have a set of steps available here and you can just follow these and go ahead and set up CI/CD as well. Now, hope this was useful. If you have any questions, feel free to reach to us directly.